Okay, we're on to page 3 of our assignment. We're going to be taking a look at problem 363. It says the ocean tides near Carter Beach follow a repeating pattern over time. The fact that it's a repeating pattern is what makes it a periodic function. It says with the amount of time between each low and high tide remaining relatively constant. In other words, it takes about the same amount of time to go to the top, to the bottom, and so on. On a certain day, low tide occurred at 8:30 in the morning, and high tide occurred at 3 o'clock in the afternoon. The water level was 12 inches above local sea level. Oh, at high tide. So the maximum, here let's color code those both with blue. So high tide occurred at 12 inches above local sea level, and low tide was 12 inches below local sea level. Okay. All right. So high tide is 12 and low tide is at -12. Okay. Assume that high tide and low tide are the maximum and minimum water levels each day. Write a cosine function in the form of f of t is equal to a, in this form, where a and b must be real numbers. Okay. And real numbers that model the water level. F of t in inches above or below the average Carter Beach sea level as a function of time measured in t hours since 8:30. So 8:30 will be the beginning on this graph below. So it's going to start at 8:30 in the morning at the bottom. This is similar to the previous question. So this is going to be 8:30 in the morning. And it's starting at the bottom. So this is -12. All right, if we were to continue upwards, I'm going to count by twos. So this is going to be -10, -8, -6, -4, -2, 0. It's going to approach its maximum eventually. So 2, 4, 6, 8, 12. And it will reach its maximum at 3 p.m. So let's maybe go by half hours. So it'd be 9 o'clock, 9:30, 10, 10:30, 11, 11:30, 12, 12:30. Oh, that's actually not going to get me there right away. So let's just count by full hours. So 9:30, 10:30, 11:30, 12:30, 1:30, 2:30, 3:30. So this will be 3:30. So it's going to reach its maximum at 3. So it's halfway between 2:30 and 3:30. And then it will come down at some point. So it took how many hours? It took 1, 2, 3, 4, 5, 6.5 hours to make it to the top. So we have to go another 6.5 hours. So the other half will be here. So that's 6.5. This is the other half, and then 6 more. So it's 3:30, 4:30, 5:30, 6:30, 7:30, 8:30, 9:30. So at 9:30 p.m., it will reach the bottom of the graph. So this is, and in between these we'll hit our midpoints. So this again is 3 o'clock. So between 8:30 and 3, that's a distance of, to get to from 8 to 12 is, 8:30 to 12 is 3.5 hours, then to 3 is 6.5 hours, so 3 hours, 15 minutes. So 9, 10, 11, so 9:30, 10:30, 11:30, and 15 minutes. So the 11:45 would be where this happens, 11:45. So in 3 hours and 15 minutes from 3 o'clock, so that would be 6:15, we would get to the midline again. So this is 4:30, 5:30, 6:30, 4:30, 5:30, 6:30. So 6:15 would be somewhere over here, and we can make our sketch of our graph. So that's the graph, that's one cycle. graphed in that time period. We need to write the equation of this graph. So if we consider 8:30 is 0 o'clock, so 0 is 8:30, and it took 13 hours to complete the cycle, that would make this 13. We need to call our period 13, and we need to find that frequency. So the frequency is equal to 2 pi over p. So the frequency is going to be equal to 2 pi over 13. So this is our frequency. So our equation should be f of t is equal to negative, because we're starting our graph at the bottom, our amplitude is 12, cosine of 2 pi over 3. We don't have a midline because we were just told that we were going to go above 12 and below 12. So this is our equation, that's our graph, and hopefully my explanation of where all the points go made sense. Let's take a look at the rest of the question. It says, people who fish in Carter Beach know that certain species of fish, that a certain species of fish is more plentiful, or meaning there's more of them, when the water is increasing. So explain whether you would recommend fishing between 7:30 p.m. and 10:30 p.m. So 7:30 p.m. would be somewhere over here. Well, 6:30 would be here. So 7:30 would be here. So 7:30 and 10:30. Explain whether I would recommend fishing for this species at 7:30 p.m. or at 10:30 p.m. Well, at 7:30 p.m., so this is 7:30, the tide is decreasing. So the tide is going down at 7:30. And at 10:30, which would occur right here, we would actually be increasing again to start the cycle over again. So this is 10:30. So it makes sense to recommend that someone attempt to fish for this fish after 10:30. So if you started too early, you would be in a decreasing tide. So in the context of this problem, it would make more sense to fish at 10:30.